everyone, how you doing? Trust you're doing good. Today I'm going to be explaining electrolysis, but basically I'll be focusing on the calculative aspect. I'm going to be looking at Faraday's first law of electrolysis first, then we are going to do some calculations under the first Faraday of electrolysis. But before I move on, what is Faraday's first law of electrolysis? Faraday's first law of electrolysis states that the mass of an element discharged during an electrolysis is directly proportional to the quantity of electricity passing through it. Now let's pick two keywords here, the mass and the quantity. So let's go to our board and do something on that. Now let's look at it. We said the mass of an element discharged during an electrolysis is directly proportional to the quantity of electricity passing through it. M here, our M here stands for the mass, and our Q stands for the quantity of electricity. Now let's move further. Now if we want to do the proportionality constant, we are going to say our M is equal to ZQ, where this Z is equal to electrochemical equivalent or electrochemical constant. But remember that our quantity of electricity equals to IT, I multiplied by T, where our I is the current, which is expressed in ampere, and our T is time, which is expressed in seconds. Note, if you are given any calculation in which the time is not in seconds, you will need to convert that particular time to seconds. They may give you in terms of hour or minutes, so you will need to convert it back into seconds because your time should always be in seconds. So here, let's now input our Q to this equation. So when we input the Q to that equation, our new equation will now be M equals to Z IT. So basically, for the Faraday's first law of electrolysis, we can either make use of this formula here to do our calculation, or make use of the second formula or the third formula. Now, let's look at some calculation under the Faraday's first law of electrolysis. Now, let's look at this first question together. It says, what is the quantity of electricity produced when a current of 0.5 ampere, remember I said current is expressed in ampere, is passed for 5 hours 45 minutes. Now, the first thing I want us to do here is to write out the parameters that we were given. Now, the first parameter we were given is current. And remember, your current is I. So we are given I to be 0.5 ampere. Then we are also given time to be 5 hours 45 minutes. And remember, I said when you are given time in hours or minutes, you will need to convert it to seconds. So we are going to convert this 5 hours 45 minutes into seconds. How do you do that? If you want to convert, let's first of all convert 5 hours into seconds first. Then we'll move back and convert our 45 minutes into seconds too. Now, if you want to convert the 5 hours into seconds, what do? We first of all multiply our 5 by 60. When you multiply your 5 by 60, it means you have converted it to minutes like that. Now, in order to convert it to seconds, you also multiply again by 60. When you multiply 5 times 60 times 60, what do we get? We get 18,000 seconds. So that is for our 5 hours. Now let's convert 45 minutes into seconds too. For our 45 minutes, remember, it's in minutes already. So we are only going to multiply 45 times 60. So when you multiply 45 times 60, it means you have converted it to seconds. And our answer is 2,700 seconds. So the next thing is we are going to add the two together in order to get our T. When you add 18,000 to 2,700, you get what? 20,700 seconds. So let's now go back. Now, let's rewrite our parameters. Our I now equals to 0.5 ampere. Our T equals to 20,700 seconds. Now, from here, we were asked to calculate Q. And remember, from the formula we just discussed, our Q equals to what? IT. I multiplied by T, right? So our Q will now be equal to what? 0.5 multiplied by 20,700 seconds. This one is in ampere. Now, when you multiply 0.5 times 20,700, what do we get? We get 10,350. Then your quantity of electricity, the unit of it is always in column. So you write C at the back, which is showing the unit. And that is that about the first question. You can see that it is very, very simple. So let's look at the second question together. Then after the second question, I'm going to give you a question to work on. And that question, when you do your workings on it, please try and send the answer to me under the comment section. Now let's look at number 2 question together. Given the electrochemical equivalent of a metal as 3.6 times 10 raised to power minus 3, calculate the mass of the metal that will be deposited when a current of 5 ampere is passed for 45 minutes. Now let's write, remember I always say that when you are given a question, you write out the parameters first. When you write out the parameters, you'll be able to know the type of formula you're going to use. So let's first of all write out the parameters that we were given. Now, the first one is electrochemical equivalent. Remember, your electrochemical equivalent stands for Z, and your Z is going to be 3.6 times 10 raised to power minus 3, right? We were asked to calculate the mass, which is our M, unknown. When the current of 5 ampere, we were given I to be 5 ampere, then it's passed for 45 minutes. We are also given time to be 45 minutes. And remember what I told you about time, that if you are given time in minutes or in hour, you will need to convert it to seconds. So let's quickly convert our time to seconds. How do we go about it? Remember, I said this is already in minutes. So what you're going to do is you only multiply the 45 by 60. And when you multiply your 45 by 60, what you get is 2,700 seconds. So that is that. So based on the 3 formulas I gave, which one do you think is appropriate for this particular question? Yes, the one that we can use for it is our M equals to Z, right, I, and T, right? So this is what we are looking for, our mass, which is going to be, what is our M? M is what we are looking for. What is our Z? Our Z is 3.6 times 10 raised to power minus 3 multiplied by, what is our I? Our I is 5 ampere. And what is our time? Our time is now 2,700 seconds. So when you multiply the 3 together, what you get is what? 48.6 gram. You know, mass is always in gram, kilogram. So 48.6 gram is the mass of that particular question. And that is that. You can say that it's very simple. Now, I'm going to give you a question to solve. And when you solve it, please try and send the answer under the comment section. Now, this is the question you're going to try and solve for me and send your answer under the comment section. I will see you in the next video. Bye.